Hello and welcome to Basin Academy. I'm Kevin Hunter. This month's safety training will cover several key areas of safety concern, including fall protection, ladders and scaffolding, walking working surfaces, and the dangers of slips, trips, and falls. Before we get started, I'd like to remind you that since this is a pre-recorded training session, you can stop, restart, and replay any segment of the video. Feel free to go back to anything you think you might have missed. Again, I'm Kevin Hunter, and I'm honored to be your instructor and to offer you this safety training from Basin Academy. Let's get started on this first section on fall protection. This training module covers working at heights, understanding the requirements of fall protection. 29 CFR 1926 Subpart M, Fall Protection. Some objectives of this training course: describe fall hazards in the workplace. Describe the basic types of fall protection systems. Describe the fall arrest system. Describe the requirements for employee rescue. Demonstrate the techniques for inspecting fall protection equipment. Fall protection is critical. Failure to have fall protection when 6 feet above a lower level is a top OSHA violation in the construction industry. In 2006, 809 fatalities for workplace-related falls were reported. Check out the pie chart to the right here. It talks about falls down stairs or steps, from building girders and structural steel, from floor, dock, or ground level, and then even falls on the same level. If you see on the right side, there's a high percentage of falls from ladder and a high percentage of falls from scaffolding and staging. Providing a fall protection system, an employer must, 1, determine if and where fall protection is required, 2, provide safe work procedures, 3, select and install proper fall protection systems, and 4th, train workers to use the fall protection systems. When is fall protection required? Fall protection is required for employees who are working 1, 6 feet or more above a lower level. 2nd, when there is a hazard of falling into dangerous equipment. And 3rd, other activities as required by OSHA and the company fall protection plan. What fall hazards exist in your work area or job site? Think about it. The fall protection hierarchy. Number 1, eliminate the fall hazard. Perform work on the ground. Engineer out the hazard. Number 2, fall restraint, positioning lanyards and guardrails. And 3rd, fall arrest, harnesses and rescue plan. With careful planning, many fall hazards can be eliminated with engineering changes or completing work on the ground before starting work. Safe practices for work: good housekeeping. Keeping a work area free of debris and clutter will reduce tripping hazards, dangers from falling objects, and prevent falls. Work slowly and carefully. Your life is too important to risk it by working too fast. Avoid dropping objects. Use lanyards for tools and equipment to prevent dropping. Taking your time is always a good work practice. Don't be a goob. Good communication is essential. Make sure employees are able to communicate. Consider establishing safe words. What do people automatically do when they hear "watch out" or "heads up"? Consider using a safe word such as "headache" to let people know something is falling. Then they know to square themselves under their hard hat and leave the area. Preventing hazards from falling objects. Many options are available to reduce the risk of falling objects by safe work practices and use of overhead protection. 1, use screens or panels on guardrails. Use strong canopies that can catch falling objects. Store materials at least 6 feet from an edge. Use tool lanyards. Always wear a hard hat. What other things can you do to prevent falling object hazards? Types of workers on the job site. A qualified person. A qualified person must have a recognized degree, certificate, etc., or extensive experience and ability to solve the subject problems at the work site. Then there's a competent person. They have been trained on fall protection usage, installation, monitoring, and inspection, has authority to take action to eliminate fall hazards, and stop work if the system is found to be ineffective. This should be a work supervisor. Next up, the authorized user, an employee who has been trained on the use and inspection of fall protection. Fall protection systems must be designed and installed by a qualified person. Warning line systems. The purpose of the warning line system is to keep workers away from a hazardous edge. They consist of ropes, wire, or chains, minimum strength of 500 pounds. They must be flagged every 6 feet. They must be erected at least 6 feet from the fall hazard. The supports for the warning line must be sturdy and not tip over easily. They must be 34 to 49 inches above the work surface. Workers must be trained to stay away. Safety monitoring system. A competent person monitors the safety of the workers. The competent person is capable of identifying existing and potential fall hazards. The safety monitor must be on the same working level as the employees and within sight. Must be close enough to communicate verbally. Monitor has no other responsibilities than monitoring safety of employees. Workers must immediately comply with instructions of the safety monitor. Safety monitoring is only to be used as a last resort when no other forms of fall protection are feasible. Controlled access zones. A combination of a warning line system and a safety monitoring system. Only certain work, such as overhead bricklaying, may occur without the use of conventional fall protection systems. Lines must be 6 to 25 feet from unprotected edge. Consult OSHA Regulation 1926.502. Safety net systems, like you see pictured here to the right, must be installed less than 30 feet below the workers, must be installed under the working or walking surface, must be installed with enough clearance to prevent the worker from striking a lower level before being caught in the net. Safety nets must be inspected once a week for wear. Objects that fall into the net must be immediately removed. Before a safety net can be used for fall protection, it must be tested by dropping a 400-pound bag of sand from the highest level an employee is expected to be working above the net. You want to make sure it's going to hold if a person falls into it. Guardrail systems. Top of the guardrail must be between 35 to 45 inches above the walking and working surface. There must be a mid between the top and the working surface. Top rails must be able to withstand 200 pounds of force. The toe boards must be 3.5 inches and withstand a force of 50 pounds. A personal fall arrest system. There are 4 important components to any fall arrest system. Number 1, the harness. Number 2, connectors. 3rd, anchorage. And 4th, the rescue plan. The system must, 1, allow no more than 6 feet of free rail, 4 feet in California and Canada, have a maximum arresting force of 1,800 pounds, no more than 3.5 feet of deceleration distance, be designed to withstand at least twice the expected impact forces. Harnesses. Harnesses can be used for fall arrest, fall prevention, and suspension. Body belts are not allowed to be used for fall arrest. The harness must be the proper size for the employee. Do not write on the harness straps or webbing. Some inks can weaken the fabric. Write your name on the tag of the harness itself. Harness safety check. Once you have donned the harness, perform a safety check. Make sure the chest D-ring is centered on the chest above your sternum. Pull your shoulder straps apart forcefully and make sure that they do not pass over the shoulders. Flip your dorsal or back D-ring up and make sure the top does not reach above the middle of the neck. Check your leg straps. You should be able to get a few fingers between your leg and your strap, but you should not be able to make a fist. Check your harness for loose straps and make sure they are all securely fastened. Calculating required clearance. Check out the illustrations here to the right. A personal fall arrest system must ensure that the user does not contact a lower level in the event of a fall. This can require nearly 20 feet of clearance. Required clearance problem. George is anchored 2 feet above his head with a 6-foot lanyard. What is his required clearance in the event of a fall? George would need 15.5 feet of clearance to avoid striking a lower level in a fall. 4 foot for lanyard, 3.5 feet for shock absorber deployment, 6 feet for height of worker, 2 foot safety factor. Here's an example of a connector. Load-bearing parts of connectors must be rated to 5,000 pounds, must be double-acting and self-locking, must be compatible with equipment being used. New ANSI standards require the gate and the gate sides to be rated to 3,600 pounds, up from 220 pounds. Old connectors are not likely to be made to the standard. Be sure to check this out. Deceleration devices. A 220-pound man falling 6 feet will generate over 5,000 pounds of force on the body. Deceleration devices are required to reduce that to less than 1,800 pounds. These devices cannot add more than 3.5 feet to the fall distance. So as illustrated to the right here, rip-stitch pack devices tear open to dissipate force. Linear shock absorbers are similar but do not have a shock pack. Some examples of lanyards. The lanyards connect the harness to the lifeline or anchor point. Never tie knots in lanyards or use them over sharp corners or edges. Lanyards are an important part of determining your fall distance. Use shorter lanyards if fall distance would exceed 6 feet. Be sure to inspect lanyards prior to every use. As illustrated over here to the right, never tie knots in a lanyard or use it for rigging. Let's talk about lifelines. A lifeline is used to connect a person to an anchorage that cannot be reached with their lanyard. Lifelines must be able to withstand 5,000 pounds of force. Lifelines should be tense enough to not add significant distance to the fall. They must be designed, installed, and supervised by a qualified person. Anchor points. Anchors must be able to hold 5,000 pounds per person attached. Anchor points may only be used for fall arrest. They should be located directly above user to minimize swing fall. Could the anchor point you selected hold the weight of a pickup truck? If not, it's probably not a good anchor point to use. Be aware of that. Equipment inspection is very important to do. Personal fall arrest systems must be inspected before every use. They also must be inspected annually by a competent person other than the user. If there is any sign the equipment has been impact loaded, remove it from service immediately. Inspections are important. Equipment in poor condition does not protect employees. Inspection tips: metal hardware. Inspect hardware for cracks, deformity, and corrosion. Ensure metal parts can move freely. Hardware that is out of round can indicate it has been impact loaded. It is important for markings to be legible on hardware so that proper rating can be assured. Inspection tips on webbing. Inspect webbing for fraying, cuts, and abrasion. Check for UV damage. Harnesses should be kept free of oil, paint, and other chemicals which can degrade the webbing. This webbing in the picture has been heavily damaged. Do not use webbing that you see with damage like this. Inspection tips regarding labeling. Labeling on fall protection equipment must be legible. If not legible, it must be removed from service, regardless of the condition of the equipment. Labels on all equipment must be legible as pictured to the right. In this illustration to the right is an example of a rescue plan. The employer shall provide for prompt rescue of employees in the event of a fall or shall assure that employees are able to rescue themselves. Every job site must have a rescue plan. If the employer relies on emergency services, they must ensure that they can arrive quickly, they are trained and have the equipment to perform a rescue. It is important that every job site has a rescue plan specific to that location. Emergency services rescue. In order to rely on emergency services for rescue, you should ensure that they, number one, can reach the location of the work in a timely manner, 15 minutes or less. Number two, must be on duty the entire time work is being performed. Number three, must have the equipment and training required to reach the worker. And four, have backup capacity to respond in the event another emergency is occurring. And number five, are informed of the hazards of suspension trauma. Always check with emergency services before deciding to rely on them for rescue. Employee-trained rescue. If the company relies on employees to perform rescue, they should designate an experienced competent rescuer who is an individual designated by the employer who, by training, knowledge, and experience, is capable of the implementation, supervision, and monitoring of the employer's fall protection rescue program. They need to designate authorized rescuers who have been trained by a competent rescuer on rescue equipment and procedures. Authorized rescuers should be listed on the job site rescue plan. Suspension trauma. Suspension trauma is caused when blood collects in the legs as a result of prolonged suspension. Suspension trauma can cause unconsciousness and even death. Symptoms include faintness, nausea, dizziness, graying or loss of vision, and unconsciousness. Suspension trauma is a serious hazard. Here are some ways to prevent suspension trauma. Frequently pumping and move the legs to prevent blood from pooling. Try to push off nearby objects to reduce weight in the harness. Use harnesses with suspension straps that allow standing in the harness. The reflow syndrome can be fatal when collected blood in the legs suddenly rushes back into the body, so be aware of this. To minimize this, do not allow a person suspected of suspension trauma to lie horizontal. Place them in a seated position on the ground with legs in front of them. In employee fall response, 1. Activate your company rescue plan. 2. Evaluate employee for injuries and, if necessary, call 911. 3. Report the incident using your company's incident report process. And 4. Investigate the cause of the fall and adjust your fall protection system to prevent a future occurrence. In summary, fall protection is required when 1. Workers are 6 feet or greater above a lower level. 2. There is a danger of falling into hazardous equipment. 3. Other situations are called for by OSHA in the company fall protection plan. A fall arrest system consists of 1. A harness, 2. Connectors, 3. Anchorage, and 4. A rescue plan. Employers must provide prompt rescue for employees or ensure that employees are able to rescue themselves. Fall arrest equipment should be inspected before every use and at least once a year by a competent person other than the user of the equipment themselves. This concludes this module on fall protection. Feel free to go back and replay any of the previous sections if you wish. Next up is ladders and scaffolding, a subject familiar to many of us. Today's safety training is broken up into 2 sections. First of all will be ladder safety, followed by scaffolding safety. There are some similarities, but also big differences, so that's why we'll cover them individually. First up is ladder safety. You see some illustrations here of types of ladders. On the left there is a portable ladder, a good heavy-duty fiberglass ladder. Then in the center is a safety angled rolling ladder that you commonly see in commercial places like Home Depot, Menards, etc. And then over to the right is an extension ladder. And I'd call your attention to the fact that that's an aluminum extension ladder and likely to have maybe a 250-pound weight limit. That's both the person climbing and anything you happen to be carrying with you too, so keep that in mind. Ladder safety. Why is this so important? Falls from ladders can cause serious bodily harm such as broken bones, puncture wounds, concussions, and possibly death. This guy in the illustration is using 2 ladders in a rather freaky situation. 300,000 people a year are treated for falls from ladders. That's a mess of ladders on the left. The picture in the middle has a questionable setup. And over on the right, I have no idea what this guy is doing leaning off this ladder, and it looks like he's near power lines, which is another huge no-no. Working at home can be just as dangerous as working in the field. Many people get hurt at their home while using ladders, which prevents them from going to work. Illustrated in this picture here on the left is a fixed ladder. Ladders that are permanently attached to a structure, building, or equipment and commonly have cages around them like this one does. Portable ladders, extension ladders, and step ladders. Some things about ladder safety, step ladders. Ladders that are self-supporting, used in situations where a wall is not available to support the ladder. It consists of 2 front side rails and 2 rear side rails, steps, spreaders, and anti-slip feet. If you look at the illustration on the right, shows the top cap and then the top step. Most ladders will have verbiage on these top steps to say, this is not a step. It might instead be a place to rest your gut. Here in this picture, 2 guys on the same ladder. Absolutely terrible idea. I guarantee you they are way overweight on the ladder. It's sitting at the wrong angle too. Ladder safety, make sure the step ladder is the appropriate length for the job you are doing. Make certain the ladder is rated for the job you are doing, and that's in terms of weight rating. Be sure to have proper footing for the ladder. That's those nice rubber feet on the bottom or the claw grip feet. Never use a ladder for anything other than its intended purpose. Never step on the top steps of a ladder. As I said earlier, the ladder should be marked. To repeat this, ladder safety, never step on the top steps of a ladder. The ladder should be marked with the highest step that you can use. If the markings are missing, tag out the ladder and replace them. Setting up a step ladder properly. Make sure the area is clean and free from anything that can cause the ladder to fall over, such as icy and slippery surfaces, or anything that could fall and hit the ladder while it is set up. Make sure the spreaders are locked before you climb the step ladder.
The spreaders are the ones between the front and back legs of the ladder, and as you can see on this illustration, this guy does not have his spreaders locked. Bad idea. A little bit about extension ladders. Consists of 4 side rails, rungs or steps, a sliding mechanism to increase the height, that's where the locks are. The foot pad is a rubber pad on the bottom that's used for hard surfaces. You can also tip those up where they have a cleat, and that can be used in soil or other types of terrain. Make sure the ladder is clean and free from obstructions. Extend the ladder if needed to the proper height. Slowly lean the ladder against the building of structure. Check to make sure the feet are securely planted. Have someone hold the base as you climb if needed. Now this particular extension ladder, the angle that it's sitting at is actually a little too steep. This bottom could slip out on this ladder. And right here is an illustration that validates that point. A rule of thumb, structure height divided by 4 to 1, the amount of base should be from the structure. For example, if you have a 20-foot tall building, we should divide 20 by 4 and get 5 feet, so the base of the ladder would need to be 5 feet away from the structure or 5 feet away from the highest vertical point of the ladder, where the ladder makes contact with the wall. Make sure to account for things like roof overhangs. The division needs to take place plumb to the point of ladder contact, as I just said. Avoid too much angle as well, because this can cause the base of the ladder to slip and cause the worker to fall. I have seen this happen on construction jobs where the bottom of the ladder was set too far out from the wall and the bottom just took off. I've seen that result in broken arms because the person's arms went through the ladder rungs, or even broken legs because the legs went through the ladder rungs. The top of the extension ladder must have a 3-foot minimum overhang past the top of where it contacts the building. So if you're looking to use this extension ladder to go up on the roof, you should have 3 feet minimum over the top of the roof. This is not only safer to get off of and onto the roof that you're wanting to get onto, but it is also much safer to get back onto the ladder too. This allows the worker to safely dismount and mount the ladder, as I just pointed out. The feet of an extension ladder may have multi-use feet. The rubber base is used for hard flat surfaces, and the rubber will provide friction to avoid slippage. The spiked ends are used for dirt or grassy areas. Be sure both feet are in the appropriate position and used on the correct terrain. Straight ladders are very similar to an extension ladder, except that they are non-adjustable in height. The safety precautions for straight ladders are the same as extension ladders. Be sure that a straight ladder is the appropriate length for the job you are completing. Here's some examples in industry where ladders are in use. This ladder that is pictured on the left is the fixed ladder we talked about earlier, which does include a cage around it to increase safety. There's also the ladder that's going up on the center picture and the ladder that's over on the right. These ladders are designed for common use and typically do include a safety cage around them to prevent falls. Fixed ladders are used in areas that require frequent access to the tops of buildings or equipment, such as pumping units, tanks, treaters, and buildings. It is necessary to use fall protection when using a ladder. Fall protection is needed and often uses a rope grab style so workers can continually climb without having to disconnect and reconnect a lanyard. A double lanyard can be used as well so workers can achieve 100% tie-off at all times. Ladder safety, follow the guidelines. Always follow the recommendations from the manufacturer. Of all the signage here to the right, the one I want to call particular attention to is the one with large letter L in it. That is an easy way to be able to tell how far out the bottom of the ladder should be and what's appropriate, and most extension ladders will have an L on the side of it to give you some guidance on what the proper angle is. Ladder safety ratings, duty ratings, this is with regard to weight. 200 pounds for a Type 3 lightweight duty, 225 pounds for Type 2 medium duty, 250 pounds for Type 1 heavy duty, 300 pounds for Type 1A extra heavy duty, and 375 pounds Type 1AA extra heavy duty. Those extra heavy duty ladders are also very heavy to move around. When climbing or working from a ladder, you must face the ladder at all times. Never straddle the ladder. Stay on the climbing side, unlike this guy in the picture to the left. Do not step on the top steps like the middle picture, and use the appropriate ladder for the job, unlike this guy on the far right. If you need to lean to the side, make sure you have proper footing and don't lean far enough that you lose your balance. If you need to move the ladder to position yourself better, climb down the ladder and reposition it. You'll definitely regret it if you end up like this guy is. More about ladder safety. 3 points of contact are required at all times while climbing, descending, and working from a ladder. If 3 point of contact cannot be maintained, other means of working from height equipment may be needed, such as scaffolding, scissor lift, man lifts, or boom trucks with man baskets. Again, here an illustration on maintaining 3 point contact while climbing ladders: 2 hands and a foot or 2 feet and a hand. When working on a ladder, do hold on, keep centered, stay straight and close to the ladder, move up or down carefully. Don't lean too far, don't reach too high, or try to reposition the ladder while you're on it. I've seen guys do it, but it's a bad idea. All right, now we will move on to scaffolding safety. Scaffolding safety training. Working safely on construction scaffoldings, covered under Standard 29 CFR 1926 450 to 452. Requirements of scaffolding. Some objectives: understand the training requirements for working on scaffolding, understand the general structural requirements for scaffolding, understand the access and working requirements for scaffolding, and understand the requirements for specialty scaffolding. The importance of scaffolding safety cannot be overstated. The National Census of Fatal Occupational Injuries reports that an average of 88 fatalities a year occur from working on scaffolding. 72% of scaffolding injuries are a direct result of supports collapsing, workers slipping, or being struck by a falling object. On January 19, 2008, an entire block of scaffolding was overturned by high winds. Fortunately, only one person was injured. There are suspended scaffolds like this one from the rooftop of this building. There are supported scaffolds on the ground like the one down on the left, and then there are other types of scaffolding available on a man lift like the one in the bottom center. Some scaffolding training requirements. All employees who perform work on scaffolding must be trained by a person qualified in the subject matter. The training must include: number 1, the requirements of the OSHA scaffolding subpart; number 2, electrical hazards, fall hazards, and falling object hazards in the area; the correct procedures for dealing with electrical hazards and for erecting, maintaining, and disassembling fall protection and other fall object protection systems; number 4, proper use of the scaffold and proper handling of materials on the scaffold; and number 5, maximum loads and load carrying capacities of the scaffold. And never forget, that includes your own body weight and any materials or tools that you bring up there too. All employees who erect, disassemble, move, operate, repair, inspect, or maintain scaffolding must be a competent person. The training must include the requirements of the OSHA scaffolding subpart, the nature of scaffold hazards, the correct procedures for erecting, disassembling, moving, operating, inspecting, and maintaining scaffolding, design criteria, maximum load capacity, and intended use of the scaffold. Scaffolding certification. Employees need to be trained on the specific hazards and requirements of the scaffolding in their work area. After completing training, they should complete a certification specific to their work area. Here's an example of a company certification program. Scaffolding design. Scaffolding systems must be designed by a qualified person and constructed in accordance with that design. A qualified person is one who, by possession of a recognized degree, certificate, or professional standing, or who by extensive knowledge, training, and experience has successfully demonstrated his ability to solve or resolve problems relating to the subject matter, the work, or the project. Scaffolding capacity. Non-adjustable scaffolding must be capable of supporting its weight and at least 4 times the maximum load. Suspension ropes and connecting hardware must support its weight and at least 6 times the maximum load. Adjustable scaffolding. Stall load on hoist must not exceed 3 times the rated load. Suspension ropes and connecting hardware must support its weight and at least 6 times the max load. Pictured here to the right, the result of an overloading scaffolding. Do you know the rating of the scaffolding you are working on? If you don't, you need to get that figured out quickly. Scaffold platform construction. The space between adjacent platform units must be less than 1 inch. The space between the platform and the uprights may not exceed 9.5 inches. Platforms and walkways must be at least 18 inches wide. If this is not possible, it must be protected by guardrails and a fall arrest system. This picture above is an underneath picture, an example of bad planking. Look at all the space between the platform planking. Before we get into the text here, take a look at the picture to the right. All that heavy brick up there, an example of poor planking and unsafe loading of the scaffolding. This is a disaster waiting to happen. Each end of a platform must extend at least 6 inches over the center line of its support. They didn't do that in this picture. Platforms that are 10 feet or less cannot extend more than 12 inches over its support. Platforms that are longer than 10 feet cannot extend more than 18 inches over its support. More about scaffold platform construction. When scaffold planks are abutted to make longer platforms, each end must rest on a separate support surface. Overlapping platforms must occur over supports and must overlap for at least 12 inches unless the platforms are nailed together. Platforms that rest on a support at an angle other than a right angle must be laid first. Platforms that rest a right angle on the support must be laid second. Note that the connecting platform is not laid first as required when it does not form a right angle. It should be on the bottom. This scaffolding also has dangerous guardrails with no mid-rail and a top rail of wire. Platform working faces. The front edge of all platforms must be no more than 14 inches from the face of the work. Faces must be greater than 14 inch if a guardrail is erected along the face side and personal fall arrest systems are used. Outrigger scaffolds must be within 3 inches of the working face. Plastering and lath operations must be within 18 inches of the working face. The platform in the picture is greater than 14 inches from the working face, as you can see. Scaffolding platform components. Wood platforms may not be covered with opaque finishes. Scaffolding components from different manufacturers cannot be mixed unless the pieces fit together without force and structural integrity is maintained. Scaffolding components made of different metals may not be used together unless authorized by a competent person. Check out all the different types of scaffolding work surfaces. If you've been on scaffolding, you've probably seen several of these. Supported scaffolds. Supported scaffolds with a height to base width ratio of more than 4:1 must be restrained from tipping by guying, tying, or bracing. First fastening device should be attached at the closed horizontal member to the 4:1 height. Every 20 feet after for scaffolds less than 3 feet wide, 26 feet for ones wider than 3 feet. The top must be secured no greater than the 4:1 height from the top. Scaffolding supports. Poles, legs, frames, and uprights must bear on base plates and mud sills or other adequate foundations. The footings must be level and capable of supporting the scaffolding load. Unstable objects cannot be used as supports or working platforms. Forklifts may not be used to support scaffold platforms unless the entire platform is attached to the fork and the forklift is not being moved horizontally while it is occupied. Supports should be plumbed and braced to prevent swaying. Suspended scaffolding from above. All suspension scaffold support devices must be able to support at least 4 times the weight of the scaffold operating at the rated load of the hoist, 1.5 times the load of the scaffold at the stall capacity of the hoist, whichever is greater. Outrigger beams must be made of metal or an equivalent and be restrained to prevent movement. Securing suspension scaffolding. Before use, the scaffolding support and connections must be evaluated by a competent person who can confirm the surfaces are capable of bearing the load. Outrigger beams should be stabilized by bolts or direct connections. They should be stabilized by solid counterweights. Sand and gravel is not acceptable. Counterweights must be designed for the purpose. Outriggers not stabilized by direct connections should be secured with tiebacks. Outriggers should be perpendicular to the bearing support. Suspension scaffold support devices. All support devices such as roof hooks and clamps must be steel, wrought iron, or equivalent material, supported by bearing blocks, secured from moving by tiebacks installed at right angles and attached to a sound anchorage. Tiebacks be equivalent in strength to hoisting ropes. Repaired wire rope may not be used as suspension rope. Remember that vents, piping, and electrical conduits are not proper anchorage points. Wire ropes for suspension scaffolding. Wire suspension ropes may not be joined unless eye-splice thimbles and connected with shackles are used. The load end must be equipped with proper size thimbles and secured by eye splicing. Ropes must be inspected by a competent person prior to each work shift. Here to the right is an example of the wire rope eye splice. Wire rope inspection requirements. Wire rope should be replaced if there is physical damage that reduces strength, kinks that impair strength or operation. 6 randomly distributed broken wires in a rope lay, 3 broken wires in a strand of rope lay, abrasion, corrosion, or flattening that reduces the original diameter by 1/3 or more, evidence of heat damage, evidence that the secondary brake has been applied during an overspeed condition. Suspension scaffolding hoist requirements. Hoist must be tested by a qualified testing laboratory. Gasoline-powered equipment and hoist may not be used as suspension scaffolds. Gears and brakes of power-operated hoist must be enclosed. Suspension scaffolding hoist must have a secondary brake that engages in an emergency. The same equipment cannot be used for both hoisting and emergency use. Accessing and working on scaffolding. Accessing scaffolding systems. When scaffolds are greater than 2 feet above a point of access, ladders, stairways, ramps, or similar means must be used. Hook-on or attachable ladders must not tip the scaffold. The bottom rung of ladders or first step of ladders may be no more than 2 feet above the scaffold supporting level. Rest platforms required at 35-foot intervals. Slip-resistant tread required on all steps and landing. Never access scaffolding by climbing on cross beams like this gentleman pictured here. Proper use of scaffolding. Never overload your scaffolding. Do not use shore or lean-to scaffolds. Scaffolds and components must be inspected by a competent person before every work shift and after any event where the scaffolding may have been damaged. Scaffolds may not be moved horizontally while employees are on them. An OSHA case report. 6 Boilermakers had just left a suspension scaffold when it fell about 392 feet, along with the foreman who was killed. The superintendent had ordered the scaffold's main support be disassembled before the scaffold was lowered to ground level. Rigging, welding machines, materials, and supplies, etc., were placed on the scaffold, and 2 1-inch wire rope hoist lines were cut free. This put the load on a single 3/4-inch wire rope hoist line, which was overloaded by 255%, and on the diesel hoist located outside the chimney, which was overloaded by 167%. Electrical clearance. Scaffolding must be kept clear of electrical lines at all times. Some insulated lines, voltage less than 300 volts, minimum distance away, 3 feet. 300 volts to 50 kilovolts, 10 feet. 50 kilovolts plus 10 feet plus 0.4 inches for every 1 kilovolt over 50 kilovolts. Non-insulated lines, voltage less than 50 kilovolts, 10 feet away, and more than 50 kilovolts, 10 feet plus 0.4 inches for every 1 kilovolt over 50 kilovolts away. I would just stay a long ways away from these lines because electricity can jump a long ways. Portable electrical tools. Metal scaffolding conducts electricity. Never forget that. An insulation failure in a power tool can electrify the whole structure. All portable electric equipment must be protected by a ground fault current interrupter, a GFCI, or a company-assured equipment grounding conductor program. Pictured here is a ground fault current interrupter, and it is a critical safety device. Working on scaffolds. Never work on scaffolding that is covered with ice, snow, or other slippery materials. That's just suicidal. Employees may not work on scaffolding during high winds or storms unless a competent person determines that it's safe anyway. Employees are protected by windscreens or fall arrest systems. Debris should not be allowed to accumulate on the platforms either. So if you're cutting and doing things like that up there, make sure your scraps get out of the way. Scaffolding should be kept clear of clutter. This scaffolding is full of trip hazards, as you can see. Working on scaffolds. Makeshift devices such as boxes and barrels cannot be used to increase working level height of employees. Ladders cannot be used on scaffolds unless it is a large area scaffold and the arrangement meets the requirements of 1926.451 F15I. The use of ladders on scaffolding is generally not allowed. Scaffolding fall protection requirements. Employees on a scaffold greater than 10 feet above a lower level must have fall protection. Employees on a scaffolding walkway must be protected by guardrails that have a minimum 200-pound top rail capacity, have a top rail height of 38 inches to 45 inches. Personal fall arrest systems used on scaffolds must be attached to a vertical lifeline, horizontal lifeline, or to a scaffold structure member. 1926.451 has special fall protection requirements for all types of scaffolding. Protection from falling objects. Not something you often think about when you're on a scaffold in a high place. Employees must wear hard hats. If there is a danger of falling objects from the scaffolding, the area below must be barricaded and employees prevented from entering. If employees need to access the areas beneath the scaffolding, tow boards, screens, and canopies must be used to protect employees from falling object hazards. What work behaviors lead to falling object hazards? And think about it. How can they be avoided? Specific scaffolding requirements. Pole scaffolding. A pole scaffold is a scaffold that is entirely made out of wood. When platforms are moved to the next level, the existing platform must remain undisturbed until new bearers have been set and braced. Pole scaffolds over 60 feet must be designed by a professional engineer. Diagonal bracing, the X-shaped supports, is required on both sides of double pole scaffolding and on the outside of single pole scaffolding. Tube and coupler scaffolds. These are supported or suspended scaffold consisting of platforms supported by tubing, erected with coupling devices, connecting uprights, braces, bearers, and runners. When platforms are moved to the next level, the existing platform must remain undisturbed until the new bearers have been set and braced. Couplers must be made of a structural steel. Gray cast iron is prohibited because it can shatter. Tube and coupler scaffolds over 125 feet must be designed by a professional engineer. Transverse bracing forming an X across the width of the scaffold must be installed at the scaffold end of every third set of posts. Fabricated frame scaffolds. These are scaffolds supported on fabricated end frames. When platforms are moved to the next level, the existing platform must remain undisturbed until new bearers have been set and braced. Fabricated frame scaffolds over 125 feet must be designed by a professional engineer. I don't know who wants to be up 125 feet on a scaffold. I certainly don't. Fabricated frame scaffolds should only be used to support workers unless specifically designed to bear loads and prevent tipping. A carpenter's bracket scaffold. Each bracket must be connected to the supporting structure by nails, a metal stud attachment device, or welding. Folding-type metal brackets, when extended for use, must be bolted or secured with a locking pin. Outrigger scaffolding. An outrigger scaffold is one with a platform resting on outrigger beams that extend out beyond the wall or structure. Outrigger beams must be secured against movement and must be braced at the fulcrum point to prevent tipping. Inboard ends of outrigger beams must be anchored by braced struts in contact with overhead beams or the ceiling or secured to the floor. Outrigger scaffolds must be designed by a professional engineer. The inboard beams must be at least 1.5 times the length of the outboard beams. Pump jack scaffolding. A pump jack scaffold is a platform supported by vertical poles and movable support brackets. Must be fabricated from metal plates and angles and have two positive gripping mechanisms. Poles must be secured to the structure by rigid triangular bracing like you see in the picture. Pump jack scaffolding is common because it is easy to adjust the working height. Ladder jack scaffolding is also adjustable. A ladder jack scaffold is made by resting a working platform on brackets attached to a ladder, or two ladders in this case. A platform may not exceed a 20-foot height. The ladders must be placed, fastened, or equipped to prevent slippage. The weight from the platform must bear on the side rails and ladder rungs or ladder rungs alone. Ladder jack scaffolds should be used for light work only. The ladders must be compliant with Subpart X, stairways, and ladders. So as you can see, there is some crossover between ladders and scaffolding. Single-point adjustable scaffolding. Single-point adjustable scaffolding is one that is suspended from a single rope and has adjustable height. The support rope must be vertical unless the rigging is designed by a qualified person and meets the requirements of 1926.452. The maximum intended load for single-point adjustable scaffolding is 250 pounds. That's you and anything else you have on it. Window washers commonly use this type of scaffolding. Two-point adjustable scaffolding, also known as swing stage scaffolds. These scaffolds are suspended from two ropes. Workers on these scaffolds must be protected by both guardrails and personal fall arrest systems. Platforms on this type should not be wider than 36 inches. Multi-level suspended scaffolds must have additional independent support lines that are equal in number to the points supported, equal in strength to the suspension ropes, rigged to support the scaffold if the suspension ropes fail. Independent support lines and suspension ropes may not be connected to the same anchorage. Support for platforms must be attached directly to support stirrups and not other platforms. Mobile scaffolding, which many people are familiar with. Mobile scaffolds must be plumb, level, and squared, must be braced with cross, horizontal, and diagonal braces to support vertical members and prevent collapse. To prevent moving, wheels must be locked. Platforms may not extend beyond the base supports. Moving mobile scaffolding must be stabilized to prevent tipping during movement. Power systems used to move scaffolding must be designed for that purpose. Employees may not ride on scaffolds while moved unless they are made aware of the move and the scaffold meets the requirements of 1926.452. So I guess if you hold on really good and you're where it's moving, it's okay. When moving, the force used to move should be applied as close to the base as possible. In summary, scaffolding systems must be designed by a qualified person. Scaffolding must be able to support its weight and 4 times the max load. Stall load on hoist for adjustable scaffolding must not exceed 3 times the rated load. Employees working on scaffolding above 10 feet require fall protection too. Portable electrical equipment must have GFCIs, protected by a ground fault circuit interrupt.
This concludes this module on ladders and scaffolding. As I said earlier, you can go back if you wish and replay any of the previous sections for greater learning opportunities. Next up is walking working surfaces and slips, trips, and falls. While this may not seem like a huge concern to some people, listen closely as the information is presented. How often major accidents occur due to these workplace safety concerns. What we'll cover today, some definitions, the cost of slips, trips, and falls, what OSHA says about it, some causes, factors that increase the risk of incidents, and prevention. What are slips, trips, and falls? A slip occurs when there is too little traction or friction between the shoe and the walking surface. A trip occurs when a person's foot contacts an object in their way or drops to a lower level unexpectedly, causing them to be thrown off balance. A fall occurs when you are too far off balance. What are slips, trips, and falls? There are 2 types of falls. A same-level fall, when you fall to the surface you are walking on. Same-level falls are more common. They are typically caused by slips and trips. Now, the second type of fall is from an elevation. When you fall to a level below the one you are walking on, falls from elevation can be severe. They are commonly caused by ladders, stairs, platforms, and loading docks. According to the U.S. Department of Labor, slips, trips, and falls are the most common occupational accident. The Bureau of Labor Statistics reported that 257,100 employees suffered injuries falling in the work environment in 2003. Of these, 174,500 employees suffered injuries falling to the same level. 82,600 employees suffered injuries falling to a lower level. Over 17% of disabling work injuries were caused by falls. 15% of accidental deaths are caused by falls, second only to motor vehicle accidents. Many of these incidents could have been prevented with general safety precautions. For example, at UWSP in fiscal year 2005, slippery surfaces such as water, ice, and grease were the number 2 cause of workers' compensation claims. Falls on the same level were the 4th cause of claims. 15 fall incidents resulted in 31 days of lost time and 48 restricted workdays. Fall claims resulted in $18,675.35 of workers' compensation. The largest fall claim cost $13,043.50 caused by a fall on ice. More on the cost of slips, trips, and falls. Slips, trips, and falls can occur almost anywhere at the worksite, and the incidents often have serious outcomes, resulting in debilitating injuries and even death. Included in the falls are pain from bruises, sprains, strains, or fractures, lost wages, temporary or permanent disability, reduced quality of life, depression, and major inconvenience. What OSHA says about this, because slips, trips, and falls can occur almost anywhere and have various causal factors, OSHA has numerous standards that address slip, trip, and fall safety for different industries. CFR 1910 Subpart D covers all walking working surfaces for general industry. CFR 1910.22 General Requirements specifies that all areas of employment shall be kept clean and sanitary. The floors shall be kept clean and dry, and where wet processes are used, aisles and passageways shall be kept clear and in good repair. Permanent aisles and passageways shall be marked. More on what OSHA says, CFR 1910.141 A3, Sanitation further specifies that the floor of every workroom shall remain as dry as practical. If wet processes are used, Proper drainage in dry standing places like mats and platforms shall be provided. CFR 1910.23, guarding floor and wall openings and holes, states that every stairway floor opening shall be guarded by a standard railing. Every ladder floor opening or platform shall be guarded with a standard toe board on all exposed sides, except at the entrance to the opening. Any floor hole that could be walked into must have standard railing or toe board surrounding it. Some causes of slips: wet spills or contamination on floors, like water, mud, oil, grease, food, etc. Dry contamination on floors, like dust, powders, wood, lint, and plastic. Some causes of slips: highly polished floors, especially marble, terrazzo, or ceramic tile. Freshly waxed floors, like you see in the picture to the right, transitioning from one surface to another, example, carpeted floor to a smooth surface. Causes of slips: sloped walkway surfaces, loose unanchored mats or rugs, loose tiles or floorboards that can shift, wet, muddy, or greasy shoes. More on causes of slips: ramps without skid or slip-resistant surfaces, metal surfaces such as platforms, construction plates, or covers on sidewalks or roadways. Metal has lower traction than many other surfaces, so it can become very smooth with wear, becoming even more hazardous when it's wet. Mounting and dismounting equipment such as trucks, trailers, lawnmowers, and other heavy equipment, climbing up and down ladders. Add water, mud, or grease to any of these surfaces and they become even more of a hazard. There are environmental factors such as rain, frost, snow, ice, or humid surfaces, uneven surfaces or terrain, and irregular surfaces such as loose gravel. Causes of trips, as you see to the right: uncovered cables, wires, or extension cords that are laying loosely on the floor, clutter, obstacles in the walkways, and open cabinets or desk drawers. More on causes of trips: changes in elevation, example, unmarked steps, carpets or mats that are not lying flat or have rolled up edges, missing or uneven floor tiles, irregular walking surfaces. Causes of trips can also happen from damaged steps, like you see here pictured to the left. Each year there are over 3 million disabling stairfall accidents, including over 4,000 deaths. Non-uniform or irregular steps, varying tread depth, varying height, or otherwise uneven steps. More on causes of trips: accumulated waste materials or debris, trailing cables, pallets, tools, etc. in walkways, objects protruding from walking surface, uneven surfaces, sidewalk or curb drops. There are also numerous common trip hazards in parking lots and garages, things like speed bumps, tire bumpers, and wheelchair ramps. Some conditions that increase the risk of slips, trips, and falls. Conditions in the surrounding environment can have a huge impact on slip, trip, and fall hazards. There can be poor lighting. There can be glare, like from bright sunlight, using bulky equipment or awkward PPEs, loud noise or distractions, temperature, humidity, or precipitation, and a traffic type or volume. Task factors also have an impact on the risk for accidents. Object carried, carrying too much at one time or carrying awkward objects, pushing or pulling objects, change in elevation or direction while walking. Age is a factor. Body shape, size, and mass, gait dynamics, how you walk, physical condition or illness, psychological factors, stress and distractions, medications, alcohol or drug effects, visual perception, and eyesight. Human behaviors have an impact on the risk for accidents. Carrying too much at once or carrying awkward objects preventing you from seeing where you are going, holding on to railings, and keeping your balance. Or like this guy in the picture to the right, decides to be a hero and carry too much at one time. Human factors increasing the risk of slips, trips, and falls: inattentive walking, using a cell phone, texting, reading, talking, and not watching where you are going while you're walking, taking shortcuts, not using clear pathways or designated walkways, or trying to wedge yourself between a couple of stationary objects, and then being in a hurry. Other human factors: poor housekeeping, allowing clutter to accumulate, not cleaning up spills in a timely manner, Using improper cleaning processes, overusing wax or polish on floors, using water to clean up a grease spill, failing to use signs when slip, trip, and fall hazards are present. And who would want to work in this environment to the right? Other factors that increase the risk of slips, trips, and falls. Pay attention here, ladies. You see the shoe to the left, high heels, use of improper footwear, not suitable for work environment or environmental conditions. Also, dress shoes, smooth surface soles, and then old worn-out shoes. Slips, trips, and falls are preventable. Modify workspaces and work practices to reduce hazards. Practice good housekeeping. Wear proper footwear. Use ladders and stairs with caution. Practice safe walking procedures. Think about workspace and work practice design. Have adequate ventilation to prevent grease and condensation buildup on the floor. Have adequate lighting to keep work areas and aisles and walkways well lit. Modify work processes to reduce splatter, spill, or release of dust, particles, oils, or liquids onto the floor via ventilation, enclosures, work surfaces, and raised edges, and then drain-offs. Perform regular checkups and maintenance on machinery to avoid leaks. You can also highlight step edges and transitions with anti-skid paint, like these yellow edges on the red brick steps you see to the right. Make sure stairways have sufficient lighting and handrails. If stairway is not often used and is not always lit, make sure access to light switches is readily available at both top and bottom of the stairwell. As mentioned, use anti-slip coating and tape where applicable, like you see on the steps to the left and then over to the right. Stairs with anti-skid coating and highlighted edges are pictured left, and ramp with anti-skid coating and highlighted edges pictured to the right. Use anti-slip mats where slip hazards are present or wet conditions are used. Use drainage or false floor where needed. Use slip-resistant floor in high-risk areas like entrances. Highlight slip and trip hazards for better visibility, like the speed bump, bright yellow, and this transition slope to the left and also in bright yellow. Some good housekeeping. Keep walkways, aisles, and stairs clean of clutter. Cover or secure cords, cables, wires, or hoses, and keep them away from high-traffic areas. Better yet, if possible, use cordless tools. Make sure rugs lay flat and secure. A warehouse with clear, well-defined walkways always help prevent accidents. Close up your desk when you're done working at it. Cabinet and file drawers, close all of those after use. Keep floors around the workspace free of cords, boxes, materials, papers, and other objects. A clutter-free, organized office workspace always helps prevent problems. Keep floors free of mud, water, grease, and debris. Clean up any spills immediately. Block off contaminated area and continue to use caution signs while the area is drying. Note, be sure not to overuse wet floor or caution signs. If they become a part of the scenery, they may not be taken seriously when there really is a hazard. People will start to ignore them. More good housekeeping. Clean surface areas regularly as recommended, following appropriate cleaning and drying procedures. Repair or replace any damaged flooring as necessary. Some information on safe walking procedures. Pay attention to your surroundings. Look where you're going and pay attention to slip and trip hazards. Walk. Don't run. Take your time. Don't read, write, or work while walking, and don't be texting on your cell phone. Use handrails while ascending and descending stairs. Take your time and don't skip steps. Bring a flashlight with you if you are going into a dimly lit area. Before you lift anything, check to make sure your path is clear and your view is not obstructed. Utilize carts. Don't carry anything that you cannot see over or around. Carry small loads close to your body. Use the elevator if you are going to another level and are carrying something that requires that you use both hands. Walk cautiously when you transition from one walking surface to another. Slow down and take small steps when a surface is cluttered, uneven, or at an angle. Wear stable, non-slip shoes. Always include slips, trips, and falls in every JSA. That's a job safety analysis. More on safe walking procedures. If you must walk on a slippery surface, wear non-slip footwear. Pay attention to the surface you are walking on. Take small, slow, calculated steps. Point your feet out slightly to keep your center of balance under you. Use handrails or other stable objects that you can hold on to if they're available. Safe walking procedures in winter. Wear appropriate footwear for winter walking, such as boots, shoes with substantial soles, or overshoes. Slow down and heighten awareness of your surroundings. Take your time when walking on potentially slippery surfaces. Walk in the clearest path available. The main walkways on campus are cleared first. Not all paths are cleared immediately, so take the extra time to walk on paths that you see are already clear. Salt is provided in certain entrances of UWSP buildings to be utilized for outside entrances or walks. Custodial department will salt entrances, but this salt is available for all to use as needed. When entering buildings, knock off as much snow remaining on your shoes as possible so you aren't creating slip hazards for yourself once you're inside the building. If you're in these buildings, make sure you contact building and grounds departments to report any areas that are in need of attention for snow clearing and or salt and sanding. Mounting and dismounting equipment safely. Make sure your shoes are clean of any mud, snow, grease, or any other slippery substance. Make sure the step, foothold, or platform you will be using is also clean, free of defects, and properly secured. Always face the equipment when mounting or dismounting. Have a firm hold with your hand and step up, placing your foot under the arch. Here's some examples of mounting and dismounting a truck. Keep 3 points of contact at all time. 3 points of contact include 1 hand and 2 feet, or 2 hands and 1 foot. Do not jump off while dismounting. Step down carefully while facing the equipment. Some notes about ladder safety. Follow the same procedure for ascending and descending ladders as for mounting and dismounting equipment. Make sure your footwear is clean and dry. Make sure ladder rungs are clean and dry. Face the ladder at all times. Maintain 3 points of contact. Place your foot on the step or rung under the arch of your foot. Lots of notes here on ladder safety. Set up ladders or step stools on firm, solid ground. Use the right height ladder for the job. Inspect ladders before using. Part of making sure that it is the right height is making sure that the ladder extends over the top of the surface that you're wanting to get onto. Inspect ladders before using. Use a 4-to-1 ratio when setting up a single or extension ladder. For example, place a 12-foot ladder so the bottom is about 3 feet away from the object the ladder is leaning against. In this case, it's the eave of the roof. If the ladder is set up in passageways or areas with traffic, secure the ladder and block off the area. Here's some pictures of ladder don'ts. Do not climb higher than the 3rd rung from the top on straight or extension ladders, or the 2nd tread from the top on step ladders. Most of them are marked, not a step. Don't attempt to use a broken or damaged ladder either. Here's more ladder don'ts. Never lean too far to the sides. Keep your hips in the center of the ladder at all times. Don't modify a ladder to make it the correct height. Don't use ladders near power lines or electrical hazards. Even dirty or wood ladders can conduct electricity. This guy on the ladder adjusting an electrical device in a pool of water is kind of nuts. Do not use a ladder that is not set up with a 4-to-1 ratio or not on a solid base. If you find yourself falling, roll with the fall. Don't reach out. Bend your elbows and knees and use your legs and arms to absorb the fall. Protect the vulnerable parts of your body, like your head, neck, and spine. Don't move if you think you hurt yourself. Wait for help. A rule of thumb, if you drop it, pick it up. If you spill it, wipe it up. Go where you are looking and look where you are going. Even the bears with their sharp claws and seemingly good traction gotta watch for ice. This concludes this final module in this month's safety training. We covered some key areas, including fall protection, ladders and scaffolding, walking working surfaces, and slips, trips, and falls. As your instructor, I do sincerely hope you enjoyed this video. In closing, I'd like to ask you to do me and everyone at Basin Safety a favor for working so hard to put this training together for you. Could you take out your smartphone and find Basin Safety on Google and write us a review? We'd love to hear your feedback, and if your comments include the words Basin Safety, it helps other people find similar quality content. As you will see when you get to the review page, many others have rated us 5 stars in the past. This doesn't mean that we were perfect, because nobody is, but it does mean we met your expectations. I sincerely hope we did that here for you today. I'm not going to expect to see the words fall protection, ladders and scaffolding, and slips, trips, and falls in your comments, but that would certainly be appreciated. I'm Kevin Hunter, signing off on behalf of Basin Academy. See you next month.